I'm going to let the number of sweets that April has be A, the number of sweets that May has be M, and June J. We know they have 90 between them, so if I add these all together, I've got 90 and I've created an equation. We also know that May has 3/4 the number of sweets that June has, so we can write M is 3/4 J, and April has 2/3 of what May has. Now, I've got M in terms of J, and I've got A in terms of M, so I can actually get A in terms of J by replacing M by 3/4 J. So it's going to be 2/3 times 3/4 J. Now you can either times the tops and times the bottoms and simplify down, or you can do it even quicker and cross cancel. It's going to give 2/4J or a half J. If you times the tops, you'd get 6. The bottom's 12, 6/12, you'd get the same thing. Let's put it all into this top equation then, because I now have A in terms of J, M in terms of J, and of course I still have J in terms of J. There's two approaches for dealing with this. The first would be to combine the fractions, but it's just a bit more involved. The easiest thing to do is actually to times both sides by 4, because that will get rid of all the fractions in there. If I times a half J by 4, I'm going to get 2J. If I times 3/4 by 4, I'm going to get just 3, so it's going to be 3J, and I'll get 4J over here. Don't forget to times the right-hand side. I'm going to get 360. So 9J is equal to 360. Divide 3 by 9, J is equal to 40. Let me just talk briefly about the fraction approach. So if we had a half J and 3/4 J, we could put it all over a common denominator of 4. So it would be actually 2/4J plus 3/4J. And then the J is going to be 4/4J, and that's going to equal 90. And then we're just adding algebra like we would normally, just add the numbers up and stick the J in front. We're going to have that many lots of J. So it's going to be 9/4 lots of J is equal to 90. Let's get rid of the equal sign, don't need that. And then I would times 3 by 4, divide 3 by 9 in the same sort of way, and again, I would get J equals 40. Since making that original video using fractions to solve it, I've seen another method for solving this that's actually a little bit better, I think. So I think it's definitely good to compare. And this second method uses ratio. So we've got April, May, and June. They were told that they have 90 sweets between them. May has 3/4 of the number of sweets that June has. So I've got 3/4 to 1. That's a possible ratio that we could write down. And straight away we could just times 3 by 4, so it's 3/4. Next, April has 2/3 of the number of sweets that May has. So April is 2/3 to 1 times 3 by 3 now, and it's going to be 2 to 3. So bring this 4 down because it's in line. Actually, we've got the ratio really quickly. The ratio is 2 to 3 to 4, which is not obvious, I don't think, when you first look at it with these fractions, but it's going to work out great now because we can add up the number of parts. We've got 9, so it's 90 divided by 9 is 10. So one part is worth 10. And then we're interested in how many sweets June has. We have 4 parts. 4 times 10 gives 40.